We have 7 segments in our lab exercise number 5. We move on to this LCD, and I'll introduce you also to the numeric keypad, how to interface it to your 8086 or any microcontroller or microprocessor unit. We'll start off with the LCD. This is from DisplayTech 204A. I think this one is available in Proteus 8.11, but kindly check with your version if this is still available. Look for a corresponding LCD, a 4-line LCD, like this DisplayTech 204A. It displays 4 lines, with each line 20 characters per line. Okay? So these are the pin configuration for a diagram. This is the dimensions of the entire LCD, and this is how it looks like in actual. But this might be encased in the DML. If you want to borrow an LCD, you could see the actual LCD display. It looks like this one, but probably with some casing. So this has 4 lines, and then each line would have 20 characters. The basic block diagram. The LCD, like most of your 8255, 8253, you need to configure it first before you could actually send or display something on the LCD panel. So you have, of course, your supply, your ground, then your control signals. I'll explain each one of them later. So there are 8 data lines. That's pin number 7 to 14. Again, that would depend on the device that you're using. So this is with respect to the DisplayTech version LCD. You might prefer other LCD manufacturers, but just check on their data sheet which one is for the data. So just like your 8255, you could read and write data, as well as you need to configure first by sending an instruction on pin number 4. So you give an instruction signal before you send afterwards the data signal. So if you want to send a command or an instruction, you use this line. You set this line to low to send out an instruction signal, and a high for a data signal. Okay. Once you have set up the data signal, that's the only time you would send what data or what instruction you would send in your these lines, DB0 to DB7. Okay. The rest are for biasing your LCD, the Ganashed power, ground, and even the backlight settings. You could configure that one also. And just like your 8255, it has registers. These are some. Instruction register, which holds the instruction, what to be the current instruction. Either you may want to clear your LCD, or you may want to shift the cursor in your LCD. So this instruction register would hold that instruction for a moment before it gets executed. Then if you have an instruction register, you also have a data register that holds the data that will be displayed into your LCD. Then we also have some flags here. You would check the busy flag. If this set, that means your LCD is still processing. There's an internal operation going on. So it could not accept any other commands or data at the moment. So wait for this to go low before you to send out an instruction or a data. Okay. Then there's also what we have a counter, which acts like a pointer. which should display the current address that is being counted. This is because the each character on each line would have a distinct address. It's like you are combining several 7-segment displays into one line to comprise the 20 characters in your 4 to 20 line LCD matrix. Okay, aside from that one, there's also the display data RAM. So it could hold up to 80 characters. Each of those characters is 8 bits, 8 bits wide. Particularly your hex is equivalent to an ASCII value, because ASCII values are usually 8 bits. Then you have your character generator ROM and character generator RAM. So that's shortened CG-ROM and CG-RAM. So this is now your 5x7 dot matrix. If in the 7 segment you have 7 segments, so this one has 5x7 segments. It's not segment but a dot, 5x7 dots to represent one character each. Now, in this product, this manufacturer has 160 different 8-bit character codes. You would see it here in the next slide. So typically you would use, you want to display the big letter A, for example, since 8-bit imong data, the higher 4 bits would be, for example, 0100, and the lower bit should be 001 to display that character. You need to place this one in your RAM, the RAM, the register earlier, so that you could display it on your LCD. Okay, but you need to specify the position or the location where this letter A would be displayed, and this is displayed in the address, which is somewhere below. Now your this type of LCD could be operated using 4-bit or 8-bit transfer. If it's 4-bit, then it's dual 4-bit transmission. But you could have a single 8-bit data transfer. So for 8086, it's 8086 is 16-bit. You only need the 8 bits of the data lines, AD0 to AD7. Okay, and that's 8-bit single transfer. Well, you could use 4-bit if you want to be daring in your programming, but that's still possible also with your microprocessor, sending 4-bit data at a time rather than 8 bits. We will not talk about the 4-bit microprocessor. What is important is the 8-bit interface. So we would use DB0 to DB7. That would be from your AD0 to AD7 line from your microprocessor. Okay, just like your 373 and 244 and 245, you have your timing diagram. When you're going to send the instruction, this is IR. Okay, after that, there's a momentary pause before you could send the data. You need to have some sort of delay before sending out the data. Okay, as you would see later in the program, there's a delay introduced before data is sent to your LCD. Okay, this is the the flow of your LCD, how to program your LCD. And in terms of instruction, you have this variety of instructions for your LCD. You may want the entire screen to be displayed. You may want to reposition the cursor to the starting point or the home cursor. home position. You may want to turn on or off the display. You may want to display or set the cursor or shift the cursor to the next position. And you have other more commands here. So you would be using these bit settings to activate the specific command. So how do you do that? Still more timing diagrams. Please refer to this one. Although at this point this is not important because we're just simulating using the simulator. But in actual, when you do the hardware specification, you should be careful and you should be critical about this timing diagram. So going to the interface now, to interface your LCD, you have to use the 8255. You could still use the 373 and the 244,
Ang
but
plano
it's
ganda
easier
naman
at this
Gcash na
point
ko bayad.
to use the 8255.
Kaya ang 1.5
So
atong
the
gihatag na ko nimo kay
output
para man atong
PA0
motor
to PA7 is connected to the data lines of your LCD, D0 to D7. Then the second port would be used for your
Dili
control.
lagi katong cash, di man ato na ko gasto.
The RS line and the E line.
Ni Papa.
So take note, the RS line and the E line would determine if you are sending instruction or sending data, as you would see later in the examples below. Then since we would be most of the time writing data to your LCD, this is held logic 0. But if you want to, there might be some applications that you need to read data from your LCD, then you just change the logic state of this one. Maybe connect it to PB2 to further refine your control with the RW signal or the RW port of your LCD. So the same setup on your 8086 side. Okay. So these are the steps when you program. You need first to write the instructions. You have to send the instructions to your LCD basing on the table earlier, this table here, which instruction you want to give to your LCD. That way you initialize the LCD and then before you send the data. So typically when you write or program the LCD, you have three what we call functions or methods. That's one for initializing your LCD, which would configure your LCD, and then the other one would be sending the data to your LCD. Here's a flow chart. If you notice, there's a delay here to give time for your LCD to receive the instruction and process it before you send out the next instruction. Okay, so here, this is your procedure or function. One for the instruction control. There are actually three controls here. Instruction control, the initialize LCD, which calls the instruction control. And then the third one is the data control. So three methods or three procedures. So it starts with the initialize LCD. So here is an example. You want to use your LCD using 8-bit interface. As we recall, it could be 4-bit interface or 8-bit interface. So these settings, 38 hex, means 8-bit interface. You would only use dual line, two lines of your display. Okay. Then you call instruction control procedure. That procedure would just send to your LCD the instruction. So in this case, your 38 hex below, this one, this value 38 hex is moved to AL, and then take note this is pushed to AX, So iyang i-save na siya ang value. Then iyang i-output sa port A. Port A is connected to your LCD. So here, you're actually sending an instruction to your port A, and then you're setting the control signal unsay buhaton niya sa imong instruction. So to do that, you have to send another data. In this case, AL is equal to 02. That is E is equal to 1, RS is equal to 0, which is you want to access the instruction register. Okay? Iyahang i-store ang imuhang instruction sa instruction register. Hello? Take note that your instruction register would be controlled by your RS and E line. So you would access port B so that ang data na 38 hex will be stored to your instruction register in your data lines coming out from your 8255. So once that is done, na kayo 1 millisecond delay. This is the same delay katong lab exercise number 5 ninyo na delay, the 1 millisecond delay. Just call that same procedure for the delay, and this time you would close the port. This time now for ready for the disabling the instruction. Okay, after setting up the LCD, you could give further instructions, and these are some of the instructions. You may want to turn off the display, turn off the cursor, or make the blinking of the cursor off or on. So if you want this setting, this would be the value that you would send to the instruction control. If you want to clear the display, then 01. If you want to increment the cursor, meaning move to the next line or the next position, and then turn off the shift, then send 06 in your instruction control procedure. And these are all possible, not all, but some of the possible combinations that you may give to your LCD command register or instruction register. So once you have done that, you have already initialized your LCD. You could now send the data. That would be this procedure. So send the data to port A, and then tell the LCD what to do with that data. So you would access now the data register. So E is equal to 1, RS is equal to 1 in port B. Then introduce the same delay, then disable. That way, the data is now stored, and whatever your data is, wherever location you want it displayed, that will be displayed in the correct position in your LCD. Okay, it's just like file operation. You need to open the file, then close the file. Just treat your LCD as one file. So this involves opening, activating, and deactivating your LCD. But this time, this is for data. This code is actually the same as your instruction control. The same process, but this one would involve data, and the instruction control would involve instructions. So here are some codes that you might want to try out. So this one would position the cursor in the third column, first line. Then whatever data you would send, that would now be displayed on the third column of the first line. This one will move the cursor to the eighth column. Take note there are 20 columns per line. This will be displayed on the second line. So this will be the value in your AL to be sent to your LCD. So starting at that column, that line, the word HELLO would be displayed, hello. Okay, it would look like this one. Okay, I mentioned that there are 20 characters per line. So each location there would be one address. That's 80 to 93 hex. Line 2 would start at C0, ending D3, and so forth for the succeeding lines. Okay. So kindly check out this code. This would serve as your template for trying out or testing your LCD connection if it works or not. Any questions at this point? Questions?
None so far, sir.
None so far, sir.
Okay, let's continue with the numeric keypad. Okay, you have been introduced to the DIP switch, dual inline package switch. So DIP 4, most of you are using DIP 4. There are also DIP 8, DIP 16, and so forth. And we also have this type of push buttons, an array or a matrix of push buttons. There's still switches. So the most common one are 3x4 and 4x4 matrix of switches, DIP switches. So these are represented by rows and columns, X and Y. This is how it looks like. The most common, I think we have this type of keypad. I think I've shown you this one in the lab. So 3x4. So only digits 0 to 9, and then the asterisk and the pound symbol are found there. The 4x4 versions, I don't know if we have a device at the DML like this one. I haven't seen. But this could be the possible combinations, how the numbers and commands are layouts. But we'll just be using the 3x4 version. So internally, the internal circuit would be just like this one. You just need to short this one, but this entails programming, manually scanning each row and column one at a time to determine which row or column that switch is activated. For example, let's look at this one here. So this one is a 4x4 matrix layout. So if you want to check if the switch number, what is the switch number? Switch number 5 is pressed. You first give a 1 in column 1. Okay. You supply a 5 volts or logic 1 here. And then after sending logic 1 on column 1, you would test row 2 if the value is either 0 or 1. If that is 0, that means the switch 5 was not pressed. If this is pressed, then row 2 would output logic 1 if it is pressed. Okay? So this is usually done. You have a program that keeps sending 1 while the rest of the columns are 0. And then you would check each row one by one which of the switches was pressed by the user. So it's like the Tinamban way of checking which switch was activated by the user. And usually you have to scan very fast to capture the switch, the activation of the switch. So sending 1, the rest 0 for the columns, then checking the rows, which one goes high. And that would now correspond to which switch is activated. So another example here, for example, so switch, if you want to check if one of the switches in column 3 is activated, either switch 3, switch 7, switch 11 or 15 is activated, you have to activate that column, then look if there's a 1 there in either row. So for example, switch 11 was pressed, so this would go high, row 3 would go high while the rest would go 0. So you would have to make a program that rotates the activation of each column one at a time, then a program that scans the rows if which switch on that column was activated. Okay? Kung asa line mo 1. So to configure this one, it would look like this one in your 8255. For a 4x4 matrix, you have this configuration. You would use port A for activating the columns, and you would use probably port C or port B for reading which switch or button was pressed here. Okay? And sometimes the programming, ang difficulty ani is ang timing, because if your code is too slow, it would not capture the pressing of the switch or the releasing of the switch. Malag ka, nakailag. And another problem with this method, you would introduce bouncing. Mo bounce every time you activate the switch. This does not, the moment there's a contact between these 2 points here, there's a ripple in the signal, which might be interpreted as 01, 01, 01, 01, until it would stabilize into 1, a purely logic 1. And that might be read by your program. Masayop yung program o basa, imbis na press na siya pero ang na-read niya is 0 because of the ripple effect. So, na problema. So most often, we will use a debouncing circuit or we use an encoder to reduce that problem, these two problems. The timing problem and the debouncing problem. We use an encoder. Okay. I think the encoder is down here. So this is the actual code to check for a 3x4 numeric keypad. Just go through this one, checking each column and then each row, which data was, which switch was pressed by the user. Pero medyo lisod kay ang timing kinahanglan paspas sa imong code. So to avoid that problem, we use the 74C922, which is a key encoder, which would make your programming simpler. All you need to do is check the data available outputs of this encoder to determine if there's a key available. So this is your 74C922 pin diagram. Okay? Ang imo lang bantayan is this pin 12 data available to determine if a valid key was pressed by the user. And that's the only time you would read out the data. Okay, these are the hex equivalent for whichever key was pressed. The hex and binary equivalent. Kung unsa nga key ang i-press. This is for 4 by 4 in this case because there's A, B, C there. If this 3 by 4, then wala ning A, B, C, D. So, do not include this yellow mark. Ang configuration nimo karon, you have your LCD in port A, port B, and then in port C, you could configure it, your numeric keypad, using the 74C922. So the 74C922 would be the one to scan. Siya na mo program, scan. Kung saan keys imong gi-press and then iyang i-read out. Kung na siya valid data makuha from this row, then data available would go high. You would capture that one. Once captured through program, you could now retrieve the data unsa nga key ang i-press. So that's 4 bits basing on this table again. Okay? So the connection, if you're using a 3 by 4 keypad, this is how you would connect it. So you have X1, X2, X3 as your column. Connect it here in your 74C922, X1, X2, X3. And your Y1, Y2, Y3, Y4, that's for your rows, would be connected here in your 74C922. Then you bias your 74C922. You have a capacitor circuit, dual capacitors here for the oscillation, OSC, and mask. And then grounding and supply. And you will notice here, if data is available, you could now tell the 74C922 to send the data. Iyang i-output enable para magawa sa Y1, Y2, Y3, Y4. Going back here. So ma-capture na siya sa imuhang 8255.
Imo giabledaan ma?
Okay?
Imo giabledaan? Sapatos?
Any question at this point? So here's an example code that you could try out.
Ano man?
Kompleto na natin. Questions or clarifications?
Basin. Lol.
No questions?
Wala rin, sir.
Okay. You will have an exercise, lab exercise number 6. But since last Monday we did not have a class, you'll be required to finish it by Friday, to be fair with the TTH class. So if you would notice, let me share my screen first. Where is it? Share. Okay. So this is lab exercise number 6. You only have one activity. You'd be using the LCD and keypad and your 8086. So initially your LCD is turned off. To turn it on, you need to press the asterisk button of your numeric keypad for 3 seconds. Okay? After 3 seconds, your LCD should turn on. Once it turns on, it will display this menu here. So only 2 options, set code and ARM system. Okay, the LCD could be turned off by pressing the pound sign for 5 seconds. At any point, you could turn off your LCD by pressing the pound sign within 5 seconds. So going back, once you are here, you're in the main menu, you let the user set the code or arm the system. Okay, in the case that the user would not set the code but select ARM system without setting the code, this is case number 1. So you would have an error message here. Error system cannot be armed, no code set. So that would be a flashing error message. Okay, maybe flash it for 3 to 5 seconds, then go back to the main menu. Although I did not explicitly place it here, but at least 3 to 5 seconds yang i-flash before going back to the menu. Now, if the choice number, if i-arm niya ang system niya, he was able to set the code earlier, then this is what would happen. This would be flashing. Warning system is armed, press 0 to disarm. So that would keep on flashing until such time the user would press 0 to disarm it. Okay? So when the user presses 0, he would be prompted to input the access code. This access code could be 4 to 8 numeric characters, and it should be terminated with a pound symbol. So after inputting the access code, you press the pound symbol to set the code and return to the main menu. This is for the inputting the set code. At the same time, in disarming your system. Okay? So if the code is valid, then you have this one. System is disarmed. And you need to press the pound symbol to go back to the main menu. And the process will repeat back and forth. So this would be displayed twice, either you're setting the code or inputting the disarm. You want to disarm the system. This message here. Any questions? So this is due on, what is it, October 16th? The 16th Friday. Sakto ba? So October 16th. Is it a Friday?
17 ang Friday.
17th. Okay, October 17, 1:30. So that's the deadline. For the lab exercise. I might check this one after the midterm exam for your case. Okay, wala man tayo klase last Monday. And then next week, GE courses. So we don't have time. So after na lang the midterms, I would check this. But make sure you upload the code by Friday, 1:30 p.m. Okay? Questions?
None so far, sir.
Okay. If there are no more questions, I leave you to work on your lab exercise number 6. You have an hour 30 minutes, 20 minutes until Friday 1:30. And then please come on time on Wednesday. Just wait for announcements. And again, let me reiterate, the discussion today is not part of your midterm exam. Only until switches 8255, 8253, and the LEDs 7 segments. Only those topics would be covered in your midterm exams. Okay, just wait for announcement if the exam will be face to face or online. Kung wala yung announcement, that means face to face. Kung na yung announcement, that would be online. I'll place it in Canvas inbox kung online ta. Okay? Okay, that would be all. Enjoy your programming. Have fun with the LCD and numeric keypad. Okay, bye everyone.
Goodbye and thank
Bye,
you.
thank you,
Sir.
sir.
Thank you, sir.
Goodbye and thank you,
Bye,
sir.
Goodbye,
thank you, sir.
bye, sir.
Bye.
Thank you, sir.
Thank you, sir.